This video reintroduces the idea of using simultaneous equations to work out the point of intersection between two or possibly more than two lines. We'll know already that for two lines which meet at a point, the x-coordinates are the same and the y-coordinates are the same. If that wasn't the case, then the lines wouldn't meet. What we have to do to establish the point of intersection is, in most cases, use simultaneous equations. Now, there are three basic types of situation we have when we're using simultaneous equations. We'll run through them just now very quickly. If we have lines in this form, where we have the x and the y term together equal a number, the usual thing we can do is scale the equations by multiplying, so that either the x coefficients, the numbers in front of the x terms, or the y coefficients match up. Once that's the case, we can combine them either by adding or subtracting to get rid of the matching variable and solve for the other one. We'll then obviously substitute back in to get the remaining value. Right, so for these two examples, for these two equations, we can either scale the x terms together. Now notice they're both positive, so if they stay positive I'll have to take one away from the other, or I can scale the y terms, and because one is positive and one is negative, I could add them together if I don't change the signs. So let's write it out. 3x plus 2y equals 7, and I've got x minus 3y equals 6. So I'm going to choose to multiply this one by 3 and this one by 2. Nice and neat. Love it. Please do it neater than this when you're doing it. Now, multiplying by 3 and multiplying by 2 means that the 2y and the minus 3y coefficients will match up in everything but sign. So we will get, we'll get 9x plus 6y equals 21, and 2x minus 6y equals 12. So, to get rid of the 6y terms, I'm going to add all the way through. That gives me 11x equals 33. So solving that, you get x equals 3. Substituting back into one of these equations, let's say I'll sub in the doesn't matter, first one, yeah. 3x plus 2y equals 7. That means I've got 9 plus something, which I'm calling 2y, equals 7. That means that 2y must equal minus 2, so y equals minus 1. Nicely done. Okay, so the point is going to be 3 minus 1. Now, like I said, folks, this is just the worked example. You will obviously make your working a lot neater than this. We'll go through it in class, so you're absolutely sure of what you're doing. Now, if both lines are in the form y equals, then all we need to do is equate the right-hand sides. If both the left-hand sides are y equals, we want to make the y's the same. Therefore, we want to make the right-hand sides the same. So let's go through this example. We've got y equals 5x minus 11 and y equals 2x minus 2. Now, we want the y terms to be the same. So in that case, these two are the same. 5x minus 11 equals 2x minus 2. Now, solving that for x, let's take the 2x to the other side. We get 3x minus 11 equals minus 2. Add 11 to both sides, so 3x equals 9. So x equals 3. We can substitute back in, let's say 2y equals 2x minus 2. So that's 2 times 3 minus 2, which is 4. So the point of intersection is going to be 3, 4. If the equations are in different forms, let's say one is equal to, or one is in the form y equal, and one is in a different form, then the y equals equation can be substituted into the other one. Let me show you an example of this. We know that y equals 3x plus 1 from here, so every time we see y, we replace it with 3x plus 1. So this equation, 3x plus 2y equals minus 7, will now look like 3x plus 2 lots of 3x plus 1 equals minus 7. Now you've got to take care to multiply this out correctly, but we'll get 3x plus 6x plus 2 equals minus 7. 9x plus 2 is minus 7. La, la, la. 9x equals minus 9. I'm going to fall off the end of the page. X equals minus 1. And if that's true, we can substitute that value back in there. So y equals 3x plus 1. That's 3 times minus 1 plus 1, which is minus 2. So the point of intersection is at minus 1, minus 2.